In less than 30 seconds, the world could come to an end. But what if Earth took a longer break? Like, what would happen if it paused for 30 seconds or a minute or even an hour? Today we are answering the extraordinary question, what happens when Earth takes a 30-second break? In about 30 seconds, your dinner could be cold. If our planet were to take a sudden 30-second break, every single clock on Earth would stop ticking. Your iPhone would freeze mid-text. The TV would pause the evening news. Cars would be left hanging in mid-drive, and that can of Diet Coke you were reaching for would just hover above your head. But while those things might not last long, the effects of a real 30-second pause from Earth itself would be a lot more catastrophic. For starters, if Earth suddenly stopped spinning, all the water on the planet would immediately rush toward the North Pole. In a matter of seconds, the equatorial bulge of our planet would flatten out into a pancake shape. In fact, if Earth's rotational speed dropped by just 1%, it would cause widespread flooding along the equator. So if the Earth were to take a full 30-second break from spinning, we'd definitely have some serious flooding issues. But thankfully, Earth doesn't need to spin to keep the water from piling up at one end. That's because there's another force keeping us from experiencing massive amounts of flooding. And no, it's not the Coriolis effect. That's a myth. Contrary to popular belief, the Coriolis effect has almost no impact on large bodies of water. The Coriolis effect is the deflection of moving objects when they are viewed in a rotating reference frame. Basically, it's the reason why hurricanes rotate the way they do. The Coriolis effect would have to be really strong to overcome the force of gravity and cause water to pile up at the poles. But on a planetary scale, the Coriolis effect is actually quite weak. It's strong enough to make a toilet flush counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. But it's not strong enough to prevent a planet full of water from piling up at the poles. No, the real force that keeps Earth from turning into a water balloon at the poles is centrifugal force. Earth isn't a perfect sphere. Thanks to its rotation, it bulges out a little bit at the equator. That means centrifugal force is a little stronger at the equator than it is at the poles. As a result, the water gets pulled away from the poles and spreads out a bit more evenly across the surface of the planet. Now, if Earth were to take a 30-second break, centrifugal force would no longer be a factor. Without centrifugal force pulling the water away from the poles, gravity would quickly cause the water to pile up at the poles. But thanks to centrifugal force, that water would have spread out a bit more evenly across the planet. So as Earth resumed spinning, the water would continue to spread out. As a result, the entire planet would get a little flatter. If Earth were to take a 30-second break from gravity, it would experience the exact opposite of what happens when the planet stops spinning. All the water would shoot into the air, the oceans would evaporate and would all float away into space. Luckily, we don't need to worry about that happening anytime soon. That's because Earth's gravity extends much further than the Moon is away from us. Even if the Moon stopped orbiting Earth completely, it would still take several months for it to get too far away for Earth's gravitational pull to have an effect on it. But let's say that instead of taking a break from spinning or a break from gravity, Earth took a break from existing. What would happen if our planet suddenly vanished from existence? The obvious answer is that everyone and everything on Earth would suddenly cease to exist. But that's only true if you believe in determinism. Determinism is the philosophy that all events are caused by prior events and the laws of physics. If determinism is true, then the fact that Earth stopped existing means that nothing else can exist anymore. But that doesn't necessarily mean the end of everything. That's because there's another school of thought known as indeterminism. According to indeterminism, not all events are predetermined. There's always some element of chance involved. Indeterminism can take many forms, but the most common form is quantum mechanics. According to quantum mechanics, there's always some amount of randomness involved in the behavior of subatomic particles. And those random interactions between subatomic particles eventually add up to the seemingly random decisions we make as humans. So if Earth were to take a 30-second break, quantum mechanics would suggest that there would still be some amount of randomness involved in how everything plays out. Maybe we make a different decision, one that causes the universe to function just a little differently. Or maybe humanity never existed at all. Of course, this is all just speculation. We don't really know how the universe works at the quantum level. But what we do know is that even if Earth did vanish into thin air, the rest of the solar system wouldn't miss a beat. You see, although Earth is the third closest planet to the Sun, it's actually the densest planet in the solar system. That means that Earth has the strongest gravitational pull in the solar system. In other words, Earth is the solar system's de facto leader. And that means the other planets look to Earth for guidance. Well, not literally. The other planets don't exactly sit around waiting for Earth to tell them what to do. They follow the laws of physics. But the point is that Earth's gravity is the force that holds the solar system together. If Earth vanished, the solar system wouldn't implode or anything. The other planets would just kind of drift off in random directions. And as for the moon, well, it would probably get flung into deep space. And that raises a pretty interesting question. What would happen if the moon were to get flung into deep space? The moon is gravitationally bound to Earth. That means it will orbit Earth for billions of years unless something interferes with the gravitational forces between the two celestial bodies. And the most likely thing to interfere with the gravitational forces between Earth and the moon is, you guessed it, another planet. If the moon were to get flung into deep space, it would eventually get sucked in by a planet with a stronger gravitational pull. But which planet would that be? Well, it turns out that there's a specific region in the solar system where the gravitational pulls of multiple planets align perfectly. That region is called the Lagrange point, or more specifically, the L4 and L5 points. These points are located at either end of the line connecting the Earth and the Sun. The L4 and L5 points are special because they're the only spots in the solar system where a small object could remain stationary relative to the Earth and the Sun. To understand how this is possible, let's imagine placing a small object somewhere in the solar system. As the object orbits the Sun, it's constantly being pulled toward the Sun's gravitational well. The closer it gets to the Sun, the stronger the gravitational pull becomes. But as the object moves farther away from the Sun, the gravitational pull weakens. The same thing happens as the object passes between the Earth and the Sun. The Earth's gravity pulls the object towards it until it reaches the midpoint between the Sun and Earth. At that point, the Earth's gravity is equal to the Sun's gravity. But as the object continues to move away from the Earth, the gravitational pull of the Sun becomes stronger than the gravitational pull of the Earth. Eventually, the object will reach the L4 or L5 point. Now, once the object reaches either of these points, the combined gravitational forces of the Sun and Earth keep it from falling toward either body. The object remains trapped in a sort of gravitational limbo until something disturbs the balance of gravitational forces. At that point, the object will get sucked in by whichever body has the stronger gravitational pull. For the Moon, that would almost certainly be the Sun. After all, the Sun is nearly 400 times more massive than the Earth. But that doesn't mean the Moon would get sucked in by the Sun right away. As mentioned earlier, the Moon is gravitationally bound to the Earth, which means it won't leave Earth's orbit for billions of years. But over time, tidal forces from the Sun will slowly stretch and deform the Moon. Eventually, the tidal forces will become so strong that the Moon will rip apart and get sucked into the Sun. So while the Moon would never get sucked into the Sun while it's still intact, it's very likely that the Sun will eventually destroy the Moon and consume it. If Earth did take a 30-second break, the Moon would probably just continue orbiting Earth as usual. But after the Sun consumed the Moon, Earth would get sucked in by the Sun as well. Luckily, that scenario is extremely unlikely. While the Moon will eventually get destroyed and consumed by the Sun, that won't happen for billions of years. And if Earth did somehow vanish from existence, the Moon would just continue orbiting Earth as usual. So even though the Moon would eventually be consumed by the Sun, Earth would have plenty of time to take a 30-second break before that happened. This whole idea of Earth taking a 30-second break is a fun one. But let's be real, it's never going to happen. So the next time you're in the middle of something and it seems like time is slowing down, just remember, it could always be worse. Earth could have taken a 30-second break and now none of us would exist. Thanks for watching.